Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
It's a pleasure to have Avi Bernstein to come and visit MSR Cambridge, and he has done some very, very interesting work on the semantic web, like on a lot of sort of topics which are sort of interest to us. So this is a visit not only for Avi to tell us about some of the projects he's working on, but for us to actually discuss ideas for possible collaborative projects that we can sort of undertake together. So Avi would be here for the rest of the evening, and if you guys want to sort of have a chat with him or discuss things, that would be great. Okay, over to Avi.
Thank you very much. It's a pleasure to be here from my side. I have to say, I'm not sure whether I'm allowed to say this in Cambridge. I was in Oxford a couple of months ago giving a talk, and my wife's family is British, partially British. And when they heard I'm going to Oxford, I was almost, the lynch mob arrived in front of the door because everybody went to Trinity here in Cambridge. So it was like, you're going to Oxford! So now I'm relieved that I can now tell my wife's family and ask for, absolution on that subject, now having been to the right place and not the wrong place. Put me up for failure. Let me start off with that. He asked, I sent him 3 subjects, and he essentially said, can you talk about all 3 in one talk? And the negotiation, the trading went down, and I kind of pushed him down to 2. So I'm going to try and give you 2 talks in one normal time slot, which is...
basically, you can have the full hour.
What? For?
The
full hour. Okay, I'll try to leave some time for questions and answer. The common denominator of both talks is really intelligent assistance, and both talks that I'm going to give you, or both the combinations, are about how can we build systems that do things for us in an intelligent manner, whatever that is. So there was this long title on the announcement. I think the short answer is really the system asking me, let me do that for you. The first approach is really an HCI question. It is about culturally adaptive user interaction. And I have this image here, and I was just thinking about this actually on the flight over. This is a company that is almost perfectly chameleoning into different languages. If you look, Coca-Cola has logos in I don't know how many languages, and in almost all of them it's recognizable as Coca-Cola. This is something that in user interaction is an extremely important point. When I went to Singapore the first time for the Semantic Web Conference 3 years ago, I thought it would be a good idea to put in a Chinese SIM card into my phone, because 3 years ahead of that, we went to South Korea, and one of my students, kind of managed to spend about 5,000 francs calling his girlfriend on his cell phone. That's about £3,500. So, for a graduate student, that was a sizable expense, and I didn't want to incur the same loss. So I said, well, you're just going to Google for, China, GSM, SIM card, prepaid, and, you're going to get ready, and you're going to do this. It's going to be fine. Okay. So I got to this website. This is the China mobile website in Chinese. As you can see, when I looked at this the first, this is not what I call a stable corporation, right? Things are bubbling up and down, and things are happening here, images are moving. This is not what a Westerner, and I'm clearly grown up in Europe, would regard as being one of the largest telco providers in the world. Up here in the top part is a very, very small button, and it says English. When you click on that button, you get this site. Now that, right? This is serious, right? We're taking on the future. This is clearly a website to which I can, give my whole trust. Press releases, event focuses, we're going to conquer the world. What China Mobile shows us here very clearly is that what you convey to your customers in different areas of the world is very different. In some way, cultural setups are almost like shortcuts to personalization, right? So you have a kind of a general personalization issue in one part of the world, and that you can generalize to more broadly population. Now, there are always exceptions. Obviously, the expats in China react very differently than the traditional Chinese, etc. Nonetheless, it's a shortcut. There are huge advantages in localization. Maybe you guys like this statistics. That's the South Korean market share in the search sector. There is Naver with about 77, Dam.net with about 10%, and whoever wins in the whole world does not win in South Korea. Very low percentage. The rationale against lies in something very simple. Right? This is our Google as we love and hate it, love or hate it. This is Naver. Again, you see the user interface is bubbly as happy. And this is Google, how they tried to approach Naver. There are no firm numbers on this, but supposedly Google did not increase their market share immensely when trying this. So what kind of other things do we see? So this is all like nice. This is what they do. But does it actually translate into user satisfaction and money? It actually does. And the problem is the fragmentation of it is quite huge. And it's much more than, usually I say that company up in Redmond would actually take Word and adapt it to all the regions. Let me just give you one more example which is going to make this abundantly clear. So my student who actually did most of this work, Katharina Reinecke, before she started a PhD with me, she wrote a master's thesis, and she went to Rwanda and developed a system called YouGÇÖve, which was a platform for agricultural advisors in Rwanda to learn about different planting, ways of planting seeds, etc., etc. And so she took all the UI books out there, she read them, and she designed the right system, right? Targon interfaces, Ben Schneiderman's books, etc., and I'm sure I'm forgetting some important books. And that was the system she came up with. She gave it to people, they hated it. They didn't use it, they clicked around in it and kind of walked away, literally. So now what she did the following. She took a 6-month localization effort, right? 6-person months. And turned the system you've just seen into something like this. Now it's completely, forget the details, but just look at this overview. The colors are different. And there's this earthy things. The navigation structure is completely different. It's actually visible. There are no like drop-down boxes, etc. And things just go differently. They loved it. They used it because it was really micro-localized. They don't just change the words. I actually maintained a Windows NT system of my Korean colleague while I was at grad school, not understanding anything because the buttons were at the same place. I just needed to know, okay, when you set up a new user, the button on the bottom left is do this and do that. So this is not just changing words. This is changing the look and feel. It's easier, more appealing, and users were able to concentrate on the learning process. Great. So all we need is one person for every country. 6 months personalization effort on something simple like that. Nobody's ever going to pay for this. So what we need is an automated way to do this, and what Kati kind of coined is this idea. Sorry, Kati is short for Katharina. Is this idea to have systems that are automatically cultural adaptive. And what I'm going to spend the rest of this part of the talk on is just quickly show you how such a system can be built. And I'm going to show you some quite astounding empirical work that shows you how good it actually works. Okay, so the first thing we had to do is we had to find background knowledge on culture. If you talk to cultural anthropologists and tell them, well, just tell me what your specification of culture is, you're going to sit there for the next months and hear discussions about what culture actually is. You're not going to get very far. The discussion is going to lead to the point where you're going to run out kicking and screaming and say, help, I just wanted a simple specification. Because they don't want you to find culture for various reasons, some of which are good and some of which are less good, at least from us. And so first you have to understand the difference between what they're trying to do, which is have a descriptive theory of what culture is. They try to describe theory as well as possible. And what we mostly want to do as computer scientists, which is have a predictive theory. Those are two different things. You can actually get a predictive theory that does not regard some of the important parts of the descriptive theory. So what many people do, they turn to this guy named Hofstede. Hofstede got a job from IBM to define the cultural property of many cultures such that the IBM sales personnel were better able to close sales deals all over the world. And he went out and categorized each country in terms of 5 dimensions. That's it, 5 numbers. A vector of 5 numbers. Really great, right? The computer scientist says, great. If you tell this to a cultural anthropologist, you're going to be crucified. You can't reduce culture to 5 numbers. And so Hofstede this is one of the most disputed theories in cultural anthropology. Okay? Nonetheless, 5 dimensions. Power distance, which is essentially a measure of how much we agree in hierarchies. I'll show you some examples afterwards, and it's going to make it clear. Individualism, how important is the individual and how important is the collective? Borgs on one side, Americans on the other side, right? Masculinity. This is not, how testosterone-driven a culture is, but how strongly do the roles of males and females differ in a culture? Not necessarily that one's running and the other one's not. It's just the roles, the things there. Uncertainty avoidance. That's relatively clear, and long-term orientation. Okay, let's look at a couple of countries here. This is the USA, right? Low power distance, high individualism, masculinity, somewhere in the middle, uncertainty avoidance, long-term orientation. What was long-term again? Almost none. China, it's almost a mirror image, not completely, right? Power distance, individualism, masculinity, uncertainty avoidance, and long-term orientation, very long. Now, he ran this study about 15 years ago. Arguably, many people argue that this thing here is changing, right? That cultures become more individualistic and so forth. But that was the measure, the numbers he had. Switzerland, power distance similar like the US, individualism not quite as high, etc. Now it's not that Swiss don't have long-term orientation. He just didn't do all the questionnaires in all countries, so some numbers are missing. So, machine learners, you have some missing value problems here. And some other ones. This is Greece, right? Uncertainty avoidance. We don't want any uncertainty. Individualism, etc. So you can see, you can place many countries here. You have this for, I think, 160 countries. You don't have this for everywhere. Now, obviously, this is not very complete, not very good. There's, one vector for the whole of China. Right? A quarter of humanity is described by one vector of 5 numbers. That's probably wrong. But we have these numbers. And what we can do with these numbers now is we can take them and we get a point for every person arriving in that 5-dimensional space. Now, even though it's so disputed, it's so handy, so a lot of user interaction research actually based on that. And Kati departed on a long series of trying to find any connection between interaction, communication behavior, as well as culture that she could. And they did a large study and derived a set of rules from it. And the rules would be things like this. Power distance. It actually turns out that people with a certain type of power distance, like nonlinear navigation, all right, I'm my own boss, I'm going to tell how I'm going to navigate through this mess. High information density, less structured data, whereas people who like hierarchy expect instruction support. I mean, this does sound a little bit stereotypical, low information density, etc. And you can collect this for each and every one of these dimensions. You can construct a set of rules. So it's essentially manually built a rule base. At the same time, okay, I'm just going to put this up. You can read a bit whilst I'm talking. At the same time, what she did is she built an ontology of user interface elements. So this is the semantic web connection. She built the big ontologies, and she classified each, drop-down boxes, etc., and kinds of information needs, and she matched them up to himself. So what's happening at this point is she now has all this information and built a system that does the following thing. The user gets asked 3 questions. Where do you live? Have you lived in any country before? If yes, where? And how long have you lived in each of these places? And it then takes, for you personally, the weighted average of the vector of all of these places weighted by the number of years respective to your full lifetime. This is really coarse, this is really, really bad, and nobody expects this to work. Okay? Based on this, some piece of machinery on the back end generates your personalized user interface. Okay? As I said, nobody expects this to work. Except it works. We took a very simple application, essentially a to-do list manager. Think OmniFocus or Things or one of these things, right? You can place things by projects, by contexts, have items, you can click them on, you can click them off. And we instrumented in the way that Kati said, and essentially what happened is we could generate, I think, 32,000 plus some number of different user interfaces. Just to give you a feeling, not for all 32,000, that would take a little bit too long, I'll show you 4. And this is where the audience participation part of this talk starts. What country is this? Because you're far away, let me just show you, right? So here are the actual to-do list items. These are the projects that you can select, right? Here are the categories. You can probably not see this, so there's little airplanes. So this is travel, work, these kind of hammer, and it's not a sickle. It's kind of a, I don't know how you call these things in English, the screw, the things to tighten the screws. You have the projects here, and here you have the actual to-do items, and you can check them, you can delete them, you can edit them. That's it. So what country do you think this is?
Korea.
Korea. Any other guesses?
Japan.
Japan. Okay. Asia. Why did you think it was Korea?
I'm judging because of the colors.
Colors.
Because that's something that I've seen in Asia, to have this sort of
Okay.
separation. But then I haven't seen the other interfaces, so it's an unfair question, really.
Why is it Japan?
Because I don't know, from the mobile phones experiences, what I've heard is that they used to have a lot of tools, or they want to have a link to a lot of different services
Okay.
in one page.
So this is actually truly South Korea. This is what, if you would enter the system as a South Korean, the color scheme is very interesting. It's these pastel colors, bright pastel colors. If you think back, it's what you saw on the Naver screen. It was also this greenish on Naver, right? This pastel greenish. Big buttons, but there are no wizards here. Power distance. So there is no strong power distance here. Let me just, as a contrast, right? Clean lines. You have a wizard here that tells you what to do. The icons are smaller. It's not a list view. Obviously we do everything in English here, not to give you any hints. Now, this is Japan. And if you think about it and look at, Japan, they're very well designed. The lines are nice. If you look at Japanese houses or dishes, I mean, the design is definitely different. And just to give you the third contrast, anybody want to take a stab at this? There is no points, No
wizard, so low power distance, I guess.
Uh-huh. So this is China. There are actually hints here, but you can't really see this. The interesting thing is that these are 3 countries that are, geographically at least very close. These 2 countries occupied that country for a long period of time. But there are still distinct differences. The buttons are much bigger here. The color scheme is obviously different. I mean, it's also lots of colors. I, Westerner, wouldn't want that.
US.
It's very close. It's actually the US version is close. This is Switzerland. And the interesting thing is the comparison to Japan. Right, again, the clean lines, clean design, but no big icons, right? The big icons here are gone.
These are the synthesized.
These are the synthesized ones. These are purely synthesized. These are the synthesized ones. Now, obviously, you're going to tell me, who knows they're good? Is the synthesization worth anything? So we ran some experiments. I'll just talk quickly about 2 experiments. Experiment number 1 is we asked people to design a user interface for us, right? So we had people from different countries, Switzerland, China, Romania, Colombia, India. The majority lived in more than 2 countries, 22 not in Switzerland from the 30 students, although most of them had lived in Switzerland. We ran the experiment in Switzerland for more than 9 months. And we asked them to lay the user interface with elements. So they had a series of questions. They had to decide, buttons, no buttons, icons, no icons, etc. And at the end, they had a layout of a user interface. And just to kind of show you how this looks like, so this is a laid out user interface, and this is the synthesized according user interface. And they are kind of close, right? So you have these button lists here, these lists, no big buttons here. On the other hand, right, this is the Chinese layouts, the Chinese guy or lady, I have no idea, the Chinese subject put this out. And at the end, they chose a color scheme. So it's not, they could essentially get very close. And what you can see here, we are kind of close. That actually encouraged us a lot to actually try and go for another experiment. I have some statistics that show you how far off from the choices we are, and at the bottom there was a chi-square test that's significant. But what's more important to take away is, if I go one back, is this, just optically looking at it from all 30, convinced us that even though it's such a coarse measure, we are on a right way to actually get somewhere. Okay? So we actually embarked on a second experiment, which I actually look at as a much more important experiment. We wanted to check the efficiency and satisfaction on a specific task. So we had 41 participants from 25 different nationalities, 20 to 36 years, 25 of which were female, high education levels, regular computer users, and these experiments were run in 3 different countries and 3 different continents. I think it was Switzerland, Thailand, and Rwanda. And the test design was, we varied, everybody ran on the baseline US as well as in their personalized version. So it's within subject design. They had all kinds of tasks that they had to do in this to-do list, and obviously some people had first their own version and then the and then the US version, and others we did this in the reverse. They had post-version questionnaires, and the whole thing ran about from half an hour to 60 minutes. Okay? So this is how it looked. Everybody had this. I think this is the US version, or at least very close to it, and then they had their personalized version. And then we saw what they were better at. We measured objective measures. So you have things like average completion time, and you see that's between 276 seconds per task. For the US version versus 215, so that was significantly faster. Average number of clicks is significantly lower, 31 versus 24. Average number of errors is not just significantly, but also the order of magnitude is 2.4 versus about 0.73. It's actually about a yeah.
Maybe the US version just really sucks.
Maybe the US version just really sucks. That is a really good question. So I don't think we had any US people in the pool. But it is what you would expect. Where is it? I was on the last slide. It's not that vastly different. I mean, just from what you can do. So we did run a post hoc test, but not US to US, and the Americans were on average okay with it. But it's difficult to do that within test. What we also were planning is doing comparisons with other countries, take other base countries, or have a manually designed version as a baseline. But I agree, yeah, maybe the US version just sucks. That is definitely a caveat that we have to go with. Subjective measures, we asked about effort expended, how much effort did they put in, asking them. Aesthetics, whether they liked it or not. And the interesting thing about aesthetics, there is something called expressive versus classical aesthetics. In the expressive aesthetics, they liked their adapted version much more than the classical. In the classical, they actually couldn't decide. We don't have any significant differences. that might be that some people describe classical aesthetics as things that are universally accepted as being right. So it's like the, what is it, the magic cut, the golden ratio, right? And things like that that usually are distributed to classical aesthetics. So what do we need to do? Now, obviously, this is the first cut. You'd like to actually do this incrementally. If we were Google, we would have a long time ago tried to see how people search differently. I'm sure they do. But not only how they search differently, should you do adaptations on the UI based on regions automatically, and we could probably collect data. Actually doing this incrementally might actually give some interesting insights about how people interact differently with data. Yeah?
Was the improvement proportional to the distance between the American versions? So some cultures are relatively similar to the Americans, and some are further away.
I don't know. Good question. I will ask Kati when I get back. I'll fire an email off to her.
Okay.
It's a very good question. We were also, another thing we were worried about is, are we all brainwashed by the systems that all got designed in the US so much by now that we just expect the US version to show up? I mean, there are all these measures that you almost can't control in these experiments because we all use American designed software most of our time. And so we expect it to look that way. Especially if you get your laptop from a fruit company, right, with the stringent design guidelines, you do expect things to happen in a certain way.
But that's also assuming that your software gets it right, that the US version that you generate is actually faithfully the design that we are already used to.
Yeah, that is true. So there is that caveat. Okay, so far. So there would be a question, are there any similarities in behavioral patterns between people? Are the clusters, do the clusters of people reveal any information? I know there is a lot of research about this in the way people behave in commercial situation, in trading actually, where the people in different parts of the world trade differently. And there are significant differences, cultural differences, supposedly cultural differences, whatever culture is, between Far East traders and Western traders. And I'm sure there are differences between European traders and US traders and the way they act. Yeah?
So the question is that in all these different changes, whenever you make a change to the interface, right, you need to sort of wait to see, because the users also adapt to that interface, and you have to basically wait till equilibrium is reached, till the users basically, in some sense, saturate, they cannot learn anymore, right? They cannot adapt anymore.
Right.
And that's a sort of a question all sort of search companies like Google or Microsoft in the case of Bing, whenever we basically we make a particular change in the interface, users first don't understand that interface, then they get used to that interface and the performance improves, but then you have to wait till equilibrium is sort of achieved, and then you can sort of get a more
like
better...
the Office ribbon thing was
exactly.
the prime example. Right?
Yeah, the ribbon thing, like initially people said, oh, that's... I cannot make that work, right? Well, why did Microsoft did it in Office 2010, right? And suddenly, and now people sort of realize that, okay, it's more productive. But that, I think, is a big challenge when you are trying to evaluate such systems. So have you had any thoughts on, when you ran these experiments, did you give the users enough time? Did they need any time? Was there any feedback that, okay, do we need to...
So my short answer is, if this is a one-shot 30 to 60-minute experiment, we don't have any long-term orientation whatsoever, right? So this is, I believe, I don't know whether it was the people at LexisNexis, like information professionals search different than the general public because they get trained, et cetera, for a long time to do so.
The question would be, as the experiment is progressing from 0 to 60 minutes, right? And if you give the same tasks, did you see what was even happening in the 0 to 60 minutes? Because I would sort of think that people would get used to, as like, okay, at the first 15 minutes, they have no clue. I mean, they're just trying to sort of see.
Yeah, but after 30 minutes, we switch the user interface on them.
Okay, I see. But so even between the 0 to 30 minutes, was there a gradual progression where there?
There was some progression, definitely, but I don't think I would, I would be extremely hesitant to run any kind of statistics on, using something for 30 minutes.
Yeah, true. So it has to be long term.
And then if you give them two user interfaces long term, I don't know whether a within subjects design is still going to do.
Mm-hmm.
Now we need to ask a Kuiper, like a serious user interface person, how would you test for this? And I think I'm going to give it a pass. I have no idea how to,
Another thing that I'm not quite clear about
Uh-huh.
is, in your experimental setup, you're effectively comparing the US version against each person's localized version.
That's right.
But this doesn't actually measure if any particular version was actually localized to that person. So
That is correct.
So wouldn't it be an interesting experiment to run to actually check if your software generates the right sort of interface, or if any randomly generated interface would outperform? So instead of comparing against the US version, why not just randomly generate an interface that does not take into account the person's cultural background and compare against that? So random interface versus culturally adapted interface.
Right.
Because maybe the adaptation isn't doing the right thing, and you're really just comparing how bad is the US version.
So, yes.
In the worst case,
Would
in
you
case your
would
system
you would you
really-
want so there is two arguments against this. The one argument is, but the baseline in this world is the US version, as much as we don't like it.
Yes, but it's not your particular interpretation of what the US version is.
That's fine. I buy that. And the second one is, I think I would need a vastly larger subject pool. And if you have run these kinds of experiments, this is a year worth of work, right? Unless you can crowdsource it, which is a completely different talk, which I'll gladly give at some other point. But actually, So let me summarize this, and because otherwise my second talk is going down the tubes. I think what we have shown is that something that was believed not to be possible, namely to actually automatically adapt for a cultural diversity, is possible. And it seems as if it gives you performance improvement. It seems as if it gives you higher satisfaction and other advantages of the advantages of people's beliefs. What it definitely is not, it's not a conclusive answer, and it's definitely just opening the door at saying there's a lot more that can be done here, that could be pursued here, learning from it, thinking about how to run better experiments. I mean, actually how to do this better. I mean, come on, how crude is it what we did? I mean, it's so crude. I mean, it's so crude nobody believed we'll get any signal. And we get signal. I had a conversation with Ed Hutchins, who wrote Cognition in the Wild, who's a cultural anthropologist, and he actually told me, hearing from this and reading the paper, said, this actually might be the first inkling that there is signal in Hofstede, right? That there is actually something there that you shouldn't just discount. There is signal in these 5 numbers that we can exploit in other applications.
But it doesn't conclusively show that. My
No.
argument would be because you are effectively comparing one particular configuration, which is what you call the US version, against something that your system tailors to the person. But let's say that the system is for some reason not working. Let's say that it's just randomly generating an interface.
I understand your point, and that's definitely. However, experiment number 1 shows that we seem to be generating something that's similar to what the person wants, or would design himself now or herself, stating that what she designs herself is not necessarily what's good for her or him. Right? We often want things that are not good for us. Just look at the tobacco industry, right? Well, maybe psychologists, if you'd be Sigmund Freud, you might argue it's good for us just on a psychological basis and not on the other. Okay, if you permit me, I will switch gears to another intelligent assistant, and that's about mining. One of the problems that I started to get interested in when I changed out of grad school and got my first job at NYU. Foster Provost was in the office next door. Some of you might know Foster Provost as a researcher in data mining and machine learning. And, I just chatted to Foster and said, hey, Foster, how do I do data mining? I have a data set. And he said, well, and that's when, like hours and hours upon long conversation started. And so, the people in the mining industry have machines. Why don't people in the data mining industry have machines to help them do things? And let me just kind of motivate this, right? So this is a day in a scientist. The scientists have some random data, and what they really want is they want to turn this data into answers. The seeming answer is KDD is easy, right? You just use data mining and this works. Well, it turns out that's not the case because, which of the algorithms should I use for induction? And then when you start asking more and more questions, you'll find out, there is pre-processing and feature construction and God knows what. And then there is post-processing. As a matter of fact, if you download a rapid miner today, which is one of the most used public domain data mining tools, you will find 1,000 algorithms in there, and you can all combine them in various different ways. And unfortunately, the story is not as easy as this. These steps can be recombined, and the process is even longer. And in short, it's a whole mess. So let's call the pros, right? The professionals, and they will know what to do. So these are numbers from Ronnie Kochavi about the KDD Cup 2000. And what you have on one axis is how many of the participants in the KDD Cup used a certain algorithm, and which algorithms did they choose. Now, this means one participant chosen. And so essentially what, in a one way you could argue, well, everybody tries decision trees because it's the default and it's easy, and then they use their own algorithms and that's it. Okay? So even the pros don't seem to go for the big variance. I would argue you could probably go to any machine learning conference and I'm convinced there are algorithms in RapidMiner that any subset of those people will have no clue what they do. Right? There are so many of them. So even the pros may not know all of them. So what we need is assistance to help us to construct valid processes, right? Let alone, wait a moment, this thing only takes discretized values as input, or only categorical, or only continuous, I mean, as a novice, who knows these things? You might know. Many people don't. You may want to choose among the valid ones to get the right one, and then you want to now manage your knowledge about prior thing. And what we argued for is that you have something called intelligent discovery assistants that help you do the discovery in the data. It turns out that we aren't the first one who think about this idea in general. We just wrote ACM computing surveys about that, where we survey like the last 30 years worth of work. So the very first part of it were statistical expert systems. Those are systems that were trying to help you to do statistical analyses. So in 2005, or before that, we built a system that takes some task specification put together by the data that you have and some desire of what you'd want out of this data, does some planning using a standard planner that gets tweaked to just spit out all the plans, to get a set of valid processes, do some heuristic ranking, and I'll show you in a minute what that heuristic ranking is, to get some ranked processes, and then run execution, where the planning and the ranking was informed by some ontology. Okay? That system worked, kind of. Just to give you an example, but the planner is a standard planner. I'm not going to go and explain planners here. That's too silly. But it kind of spits out things, and obviously the explosion of the plan space is a huge problem, right? The more operators you have, and I'm going to talk about this in a second. Our prototype at the time just used a very small ontology, but with about 20 operators. So we could just exhaust the plan space. But now I have this. And I can ask any set of people, which one is the best process to run? And the right answer is, well, we don't know, because you don't know the data, and you need to try, and no free lunch comes and visits us here, right? So you need to do some ranking. Now, what is the dimension to rank by? You know, speed, accuracy, comprehensibility. I have built models with physicians. They don't care how precise the model is. They want to understand the model. So forget your support vector machines, right? Just forget them. You know, decision trees are maybe something they understand if they're pruned sufficiently. They want to understand them because they sign in the end, and it's their name that's on the line if the wrong treatment gets done, right? Difficulty of running might be one. So at the time, we just devised some heuristics, some very simple heuristics, and I'm just going to tell you one. They're so simple, they're almost laughable. So we took some UCI data sets, as I told Pushmeet. The best and the worst things that happen to machine learning is the UCI data set collection. We took a handful of algorithms, which resulted in 16 plans, exhaustively planned. This is a laughable amount, I know. We'll get to better numbers soon. And we had two different ranking approach. One was we just ran everything on credit G and said, the way it performs on credit G, that's as good as it will perform everywhere else. And the second one was we had something where, what I call the expert ranking. I picked a couple of people at the department's brain, you know, how good is this algorithm? How fast is this algorithm? And I just added up the scores they gave him for all the parts of the algorithm. And you know, for speed, you actually get a fairly good prediction. So what you see here is the two different ranking methods, and that's the Spearman of the actual performance versus the performance. So we're in the 0.9s. That's very good for speed, which is what you would have expected. You know, if I ask you, is a support vector machine faster in the learning step than some instance-based learner, I think we would all very quickly converge on some good answer or on a decision tree learner. But if I ask you which is more accurate, I would argue that we would argue for a long time. And so for speed, we got very good results. For accuracy, obviously, we didn't. So we said at the time, there needs to be something to improve this. And what we can do is we can trade off computing time versus accuracy and prediction, so we can run experiments, right? We can run auto experimentation. And again, this is at the time. I mean, those things were run in like 2002, 2003. What we showed is you can take a very small subsample of your data, run all the plans on it, assuming you can. With 16 plans, that's not a problem, and make a prediction on what is the ranking going to be and get bigger and bigger. And all we showed at the time is this converges. This somehow converges. So all we're arguing, if you're ready to trade some time versus space, you might be able to get reasonable ranking. More research needed. That was our result in the 2005 paper. Another thing we did is we said, okay, now let's get to some more realistic data. We took the KDD COP 98. KDD COP 98 is a target marketing process where it's the question, who do I mail a letter? And we asked ourselves, can we compete? So you have roughly 100,000 records in the training set, roughly 100,000 records in the test set, and you need to, based on a donation frequency and a certain mailing cost, decide whom to mail a letter or not. And the default strategy, mail everybody, gets you a profit of about 10K. We ran our system on this, and the top process actually is below the default, but after that we actually get a very nice ranking here, and our top process is slightly above the default. Okay, so we say, well, that doesn't tell us how good we actually do. So let's compare to what the participants in the KDD COP do. Note that participant 21 actually lost money. They systematically sent to people who wouldn't donate. Now, there are some people up here who do significantly better. And the question was why? So we went back and looked at the publications those people wrote and said, why are those people so much better than the rest, right? I mean, those people must know something that those people don't. It can't just be that they use the newest super-duper induction algorithm, especially not where they come from. Now, Urban Science turns out is, or was a company, I don't know whether they still exist, let's assume they do, that actually is in target marketing. And they know something about target marketing that other people may not have thought about, which is actually very simple. You actually have two parts of this problem. One is, what is the probability that somebody's going to donate again? And the other one is, how much is the person going to donate assuming they're going to donate? So what you really need to do is you need to take your data and you need to learn a class probability estimation on what's the probability somebody's going to donate, as well as a regression, what is the donation amount, and then you get an expected value. If you do that, you get better measures. And if we put that template into our planner, we're actually up here with the best results. Okay? So that is the second argument that we said. You need actually to collect information on past runs and kind of get a knowledge base of how do I do this right? What is the right process? And it's not just a linear process, right? They are very complicated combinations. So this explodes the planning problem even further. So what was the problem with the system? The problem was multifold. First of all, we only had few operators. Plan space explodes. Ranking is a weak proof of the concept at best, the ranking we had at the time, and we just had one template. Nonetheless, I think it's instrumental that we build such systems that help me do this, because most of the people in the world otherwise will not use the power of those statistical instruments. Now, I have one person working for me who's been a data mining professional for soon to be 2 decades, and he always says, well, those people shouldn't do statistical analysis anyhow, right? They're just shooting themselves in the foot, and they're doing it with a machine gun rather with a bow and arrow if we give them machine learning. That is one way of seeing it. I think we should be thinking of how to help those people to achieve their goals at least a bit. Interestingly enough, that person decided to join me when we were starting to be one of the collaborators in an EU project called IGÇÖll. IGÇÖll was a project where a couple of data mining machine learning researchers wanted to build a system that helps people who do research in kidney and uterine pathways. What goes wrong with your kidney and your uterine elements based on some information that you gather on it, some tests that you run on it, to improve their research. So here are clearly professionals, not data mining professionals, and we want to help them build a system that helps them do their job. We built a planner, etc., that does things differently than our first planner. We use something called HTN planning. I don't know how much you know that. It's hierarchical task networks. Essentially, rather than try and plan the whole space, you get templates and you try and increasingly refine the templates using ontological information, what can be replacement for certain abstract processes. And based on these task networks, you essentially prune your search space. We added something to it called attribute grouping. What you find in these biological data sets is huge numbers of attributes or features that all behave very similar. They are all a measurement of a certain kind, some metabolic feature of some sorts, right? In order to not think about each of those elements, I can do these 50,000 things to these, and these 50,000 things to these, and these 50,000 things to these, and then get the combinatorial explosion of the plan space. You actually plan this once, and then know now I can apply things to the whole group because they're all similar groups of attributes. And then plan groups. You can sometimes see plans that essentially have for one step a whole bunch of alternatives and then they go back together again and then you get a whole bunch of alternatives again. So we grouped these and had essentially a more abstract representation of the whole plan space. The result of it is a product that is a tool which you can download for free. If you download RapidMiner, you can get a plugin which in so-called 7 steps will get you to some supposedly sometimes very complex combination. You can import your data. Then it analyzes the data. It gets some metadata about the data. Is it continuous? Is it not continuous? You then choose the tasks you want, predictive modeling, parameter discovery, some other things that you have. So that's your task. It then plans the plan space, and it will try to rank the performance of those plans. Now, this ranker that's built into the current system is a ranker that essentially tries to infer from how other people use the operators whether this is a good operator or not. Its performance is questionable. I'll get to that on the next slide. And And then you can fetch the plan and execute the plan. So this allows a novice to get to the point where they can at least run things and run auto-experimentation. So this was one of the successes of that project, and in the last month since the end of the project, we have engaged in a massive exercise of trying to use auto-experimentation to make predictions about which of the possible processes are actually good ones to choose and not. And all I can give you is a glimpse on how good we do these days. This is currently under review. So there is this huge machinery that runs auto-experimentation, and then you come to it with a new problem, right? And you ask, which is the best process I should run? And it will give you a ranked list. And what you have here is a graph that shows you from the predictions, if I give you the 20 top ones, how far away in terms of accuracy difference am I from the best performing process altogether? So in a sense, what this point here means is that if I give you 20 processes, if this ranker gives you 20 processes, it will, the best one of those, and I can't necessarily tell you which ones it is, you need to run all of them on some kind of cross-validation data set, is going to be within 0.05 accuracy, within 5% accuracy of the best performing one. And that's automatic.
Your accuracy loss is additive or fractional? You're saying within 5% in total in accuracy, or your accuracy would be at least 95% the accuracy level of the optimal one?
That's right. I'm 95% below, I can't be above, right? The optimal one. So within those 20 processes is a process that gets within 95% of the best one. And that, I think, is damn good, right? It means that somebody without any knowledge in this, having this machinery, can get close to what the best thing can be. It's not quite there, but can get close. That's it. I told you that I'm a strong believer in intelligent assistant. We may want to be sure that we ask ourselves what we tell the intelligent assistant what to do. I tried to get my talk into the hour. I think I just have another 2 minutes for you guys to ask questions. I talked about culturally adaptive user interaction, an area where I think we scratched the surface at most, but is very exciting. Kati is now postdocing at Harvard and continuing work. We are getting work from some data from some internet companies where we really have truly large data sets, but only on very limited tasks. So this is very exciting. Expect to hear more about this. And we have this thing about the intelligent discovery assistance, a piece of work where I think if we want to truly make an impact in a larger sense, where not just a few selected specialists can use these algorithms, we may want to think how to put more efforts in. Those are two domains where I think nobody would have expected 10 years ago that intelligent assistants can do anything. Now we're there where we can at least do something, and I think we should all strive to get more domains and do more work. Thank you. That's it. I'll take questions.